Today we are going to see in set theory how Venn diagrams can be used. Suppose the problem is like this. If number of elements in the set A is 15, number of elements in A union B is 29, and number of elements in A intersection B is 7, then find the number of elements in the set B. First we draw the Venn diagram. This is the set A, this is the set B. This is the common part to A and B. This is called as A intersection B, A and B. This part you will find that A is there but B is not there. So this can be called as A intersection B complement, A intersection B dash. And this part can be called as A is not there but B is there. So A dash complement B. So here set A is divided into two parts, A intersection B complement and A intersection B. Set B is also divided into two parts, A intersection B and A dash intersection B. Only B, not A. Now here it is given that A intersection B is 7. We can write 7 here first. A intersection B is 7. Now number of elements in total set A are 15. So this total set A contains 15, out of which 7 are here. So 15 minus 7, that is 8 will be in this part. So here A intersection B dash contains 15 minus 7, that is 8 elements. And total elements in A union B is 29. So this complete figure contains 29 elements. Now we want how many elements are there in this part. So from 29, if we subtract this 8 and 7, that is 15, we get 14. So A dash intersection B, only B, contains 14. But we want number of elements in the set B. So that is this and this together. A intersection B contains 7 and A dash intersection B contains 14. 7 plus 14 is 21. The number of elements in the set B are 21. This we got with the help of Venn diagram. Without Venn diagram also, with the help of this theorem we can get. The theorem is that number of elements in A union B is number of elements in A plus number of elements in B minus number of elements in A intersection B. Here number of elements in A union B is given as 29. Number of elements in A is given as 15 and number of elements in B we don't know, so that we write as it is. Number of elements in A intersection B is given as 7. This is an equation and this is the unknown part, n number of elements in B. Now from 29, this 15 transpose to that side will subtract 29 minus 15 and 7 transpose to that side will add. So 29 minus 15 plus 7 is equal to NB. So this comes out to be 21. Number of elements in the set B is 21. This 29 minus 15 we can do first as 14, and to this 14 we can add 7 to get 21. So this we have done here without the help of Venn diagram. Venn diagram is shown here but not used for finding out that. We have found out with the help of calculations. Here in a hotel there are 125 students, out of which 80 drink tea. Now T, the set T I am showing by the letter capital T. 60 drink coffee. C for the set of students who drink coffee. 20 drink tea and coffee. These 20 are both tea and coffee. Find the number of students who do not drink tea or coffee. Now there are 125 students, so this is a universal set. Universal set is generally denoted by a rectangle. So this is a universal set which contains 125 students. Now it is given that 80 drink tea. Number of elements in the universal set is 125. Number of elements in the set T is 80. So this circle should have only 80 total. Then number of elements in C The number of elements taking coffee is 60. So within this circle we want 60. And number of elements in T intersection C, tea and coffee, there are 20. So this is 20. As we did before, here number of elements, number of students taking coffee are 60, out of which 20 are written. So 60 minus 20, so 40 are there who take only coffee, no tea. Likewise here, number of students taking tea are given as 80, and t is equal to 80, out of which t intersection C is given as 20. The count of t intersection is C is 20. If that is subtracted, so 80 minus 20 is 60. 60 students take only tea, no coffee. 20 students take tea and coffee, and 40 students take coffee only, no tea. This is done with the help of Venn diagram. If we use the theorem, number of elements in T union C is equal to number of elements in T plus number of elements in C minus number of elements in T intersection C. Now here, number of elements in T union C will be 80 plus 60 minus 20. Number of elements in T is 80, number of elements C is 60 minus T intersection C count is 20. 80 plus 60 is 140 minus 20, that is 120. So total here are 120. Now we are asked find the students who do not take tea or coffee. That means out of this. So what is the number of students in this part? Neither tea nor coffee. So number of elements in U is 120, 125. From that 120 is subtracted. So we get 5. 5 students do not take tea or coffee. T union C means they take either tea or coffee. T union C complement will mean neither tea nor coffee. So from total number of students U 125, if we subtract the number of students taking tea or coffee, that is 120, we get the answer 5. The answer is 5. Observe the given Venn diagram and write the following sets. This Venn diagram is given and these sets are asked. A. So A means this set. A contains X, Y, Z, M, N. Answer A is X, Y, Z, M, N. Then set B. Set B means this set. So that contains this element M, N, P, Q, R. B contains M, N, P, Q, R. Then A union B. A union B means within these two circles all elements X, Y, Z, M, N, P, Q, R. A union B will contain X, Y, Z, M, N and P, Q, R. U. U means universal set. So all the elements in the rectangle. So X, Y, Z, M, N, P, Q, R, S, T. In the set U, we have X, Y, Z, M, N, P, Q, R and S, T. Now A dash. A dash will mean from the universal set, you take out the elements in the set A, U minus A. So from U, if you delete these elements, you are left with P, Q, R and S, T. P, Q, R, S, T is A dash. Then you want B dash. B dash means from the universal set U, you take out the elements in B. So you are left with X, Y, Z, S, T. X, Y, Z, S, T. And you want A union B complement. So A union B is this set and its complement means from U, if you take out all these elements, you are left with S, T. So A union B complement means the set S and T, the set of the two elements S and T. Then out of 100 persons in a group, 72 persons speak English, 43 persons speak French. Each one out of 100 persons speak at least one language. Then how many speak only English? How many speak only French? How many of them speak English and French? So here you can take the set as A, B. I have taken E and F so that immediately we shall Understand? E means English, F means French. U is the universal set. Universal set is denoted by a rectangle. E is the set of persons who speak English. F is the set of persons who speak French. So out of 100, so total here, all here will be 100. 72 persons speak English. So this set should contain 72. Then 43 persons speak French. So this should contain 43. Each out of 100 persons speak at least one language. So there are no persons outside the circles, neither English nor French. There is no candidate having either neither English nor French. Either they speak English or they speak French or they speak both. Now here we shall use the theorem number of elements in E union F is equal to number of elements in E plus number of elements in F minus number of elements in E intersection F. Now number of elements in E union F, that is this, all elements are 100, is equal to number of elements in E. E means those who speak English, there are 72. Number of elements F is 43 minus number of elements E intersection F, which is not given. So let us solve this equation. If we transpose this to left hand side, this minus will become plus. So number of elements in E intersection F is equal to 72 is already on right hand side, so that will not change. 43 is right hand side, that remains on right hand side, and 100 is transposed from left hand side to right hand side, so that becomes minus. So 72 plus 43 is 115 minus 100, so 15. So there are 15 persons who speak English and French. Now if we want number of persons speaking only English, so total number of people talking English are 72. From 15 if we subtract, so these 57 people, they talk only English. If we want only French, so number of people talking French are 43, from which if we subtract this 15, we get 28. That means 28 people talk only French, and we want English and French, so that is 15. If we see here, 57 plus 15 is 72. So 72 people speak English, that is correct, and French is 15 plus 28, that is 43. 43 people speak French. Next is on page 17, question number 4. 70 trees were planted by Partha and 90 trees were planted by Pradnya on the occasion of tree plantation week. Out of these, 25 trees were planted by both of them together. How many trees were planted by Partha or Pradnya? Or means union, and means intersection. This is A and B. This is A intersection B. And A or B means all these three. This is union. So, number of trees planted by Partha or Pradnya means number of elements in A union B. That is number of elements in A plus number of elements in B minus number of elements in A intersection B. Number of elements in A, that is, here both are starting with P, Partha and Pradnya. So I have not taken the letter P. We can take any letter. In the beginning we can write, let A be the set of plants planted by Partha and B be the set of plants planted by Pradnya. Now here A, number of elements in A is 70 and number of elements in B is 90. 70 trees are planted by Partha and 90 trees are planted by Pradnya. So Na is 70, Nb is 90 and common are 25, A and B. So 90 plus 70 is 160 minus 25, that is 135. So this all three together will be 135. Number of trees planted by Partha or Pradnya. A union B means number of elements in A or B. So that is 135. Now this is on page 17. If number of elements in A is 20, number of elements in B is 28, and number of elements in A union B is 36, then find number of elements in A intersection B. Here again we can use the theorem. Number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Number of elements in A union B is given as 36 is equal to number of elements in A is 20 plus number of elements in B is 28 minus number of elements in A intersection B we don't know. Now this again I am transposing to right to left. So this minus has become plus. Number of elements in A intersection B is equal to this 20 and 28 already are on the right hand side. They remain as it is, and 36 is transposed from left to right. That becomes minus. 20 plus 28 is 48 minus 36, that is 12. So number of elements in A intersection B is 12. Represent the union of two sets by Venn diagram for each of the following. Here first is A is 3, 4, 5, 7, B is 1, 4, 8. Now if you want to represent by Venn diagram, first you should find out A intersection B, that is common elements. So 3, 4, 5, 7 and 1, 4, 8. 4 is common in both. So A intersection B is 4, that we have to write here 4. And then we have to complete this A. So only A, that means 4 is common to both, that is written. Now remaining is 3, 5 and 7, that we have to write here. And from B, in B there are 1, 4, 8. So 4 is already written, 1 and 8 are written here, only B. So first we have to find A intersection B. That is the singleton set 4, the set containing only one element 4, and fill up the Venn diagram. So 4 is written here. Then we have to fill up the remaining elements in the set A. So 3, 5, 7 are the remaining elements, those are written here. Now fill up the remaining elements in the set B, that is 1 and 8. The answer in the textbook is wrong. 1 is not shown. This one is not shown in the textbook answer. And they want A union B. So A union B means all these elements. 3, 4, 5, 7, 1, 8. All these elements will be in A union B. Second question we shall attempt on the next sheet. Solution to the question number 7, sub question number 2. Here P contains the elements A, B, C, E, F. A, B, C, E, F, and Q contains the element L, M, N, E, B. L, M, N, E, B. As before, first we shall find P intersection Q. You will find that B and E are available in Q as well as in P. So, P intersection Q, common elements are B and E. Those are to be written in the common part first. Then fill up the remaining elements in P. In P we have A, B, C, E, F, out of which B and E are written here. So remaining are A, C, F. A, C, F are written here. So all the elements in P are written here. Now all the elements in Q should be written here. Here B and E are already written. So remaining are L, M, N. Those are written here. So here, as I told you before, first you have to find P intersection Q, and that you have to write here. Fill up the remaining elements in P and write here. Fill up the remaining elements in Q, write here. Now P union Q means all these elements, no repetition. So these repeated elements are to be taken once only. So here A, C, F, B, E, L, M, N. A, C, F, B, E, L, M,